kind of scrape a website once, you have to change it every time the website changes. And it's a pain in the ass. So whatever is a pain in the ass sounds like a perfect opportunity to use AI or large language model. My neighbor trash just flew over for some reason. Anyways, that's what I did. So I used a combination of LangChain, OpenAI Functions, and Playwright, Python, and Beautiful Soup to do just that. And the beauty of this code base is that you can get it up and running right away. And if you want, you can slap on top of it a server, like a fast API server, so that you can serve this to your front end, so that your front end can like basically scrape like Amazon or Best Buy and then display all that information on your own website without having to worry about whenever those website changes its content or the way it display content. So I'm gonna break this down to two parts. So the first part is I'm gonna just go through this really fast and show you how it works. The second part is when I'm gonna break this down into details and explain why I chose the tools that I did and the reasoning behind, why I did those things and how things work. So let's just get started. Okay, so here I have the code base. So, when you clone it down, you should be able to see this structure here, and you just have to do two things. So you create a virtual environment, you enter that environment, and you install all the dependencies for this code base. So as long as you have this showing when you open up your terminal, you're good. So it's just to show you how this works. Right now, what I'm going to do is I'm going to go to the Wall Street Journal main page and then try to get all the information from that page. So I want to get all the articles titles, all the article summaries, and some extra information about each article. And this is all I have to declare. Back in the day, but I guess back when OpenAI Functions or LLM wasn't as popular, you have to declare a dictionary of like all the HTML tags that you need to scrape. But this is all I have to do. And let me show you how this works. So I'm going to press enter. It's going to start scraping, which means it's going to go to wallstreetjournal.com, get all the content, which is kind of like the raw HTML content. And then it's going to pass all of that through the LLM. In this case, it's the OpenAI GPT 3.5 Turbo. My neighbor's trash is just flying outside my patio. It's kind of distracting. But anyways, we'll just have to wait for a little bit so that we're sending all the HTML to OpenAI, right? And then we're getting back all the news articles. See how crazy this is? Just like magic. So we had this really nice array of things that it was able to scrape from the website. We got the extra information that I asked for. This is kind of like, oh, surprise me, whatever new information that you think that I should read, but I didn't declare, which one to look for. And I got the summary of each articles, which is kind of like the short blurb underneath every article's title. And I got the title. So this is pretty nice, right? And let me show you another example. This one, it's going to be a kind of like an e-commerce website. So for my next trick, I'm going to show you how to scrape e-commerce like website. So like, kind of like an online shop with a lot of items on them. So here I have an example of this website called AppSumo. And all I have to do is change the schema and go back to my terminal. You can see I have a lot of errors here. That's the magic of movie making. So I'm just gonna run this, and it's gonna do the same thing. Go to the website, script the content, the HTML, and then pass all of that to our large language model. And we just have to wait a little bit. And now we got back a couple of items. So if you look at the schema here, I specified that I wanted item title, item price, and some extra information. And then there's this last key here where you can declare something like, all the properties or all the information that you really want, because sometimes there might not be information present on the page, maybe for price or, but these are the things that you absolutely want, and you can declare that as required. And I'll go into explaining why they're called what they're called. So yeah, a really nice array of, you have, for example, this item called Frontly, the price of $49. And then if you want, you can actually go onto this website and see if that item actually exists. Frontly. Yes, it does actually, at $49. Give me Frontly. Yeah, $49, lifetime. So, just like magic, right? So now it's part two. Part two is where I dig into this and try to explain to you how this works. So let's start with the main.py file, which is the gateway to this. We run a kind of like an asynchronous function that takes into account a URL, some sort of schema. So a schema here is just a way for us to declare what we want out of our scraped content. And the schema is just as simple as declaring either a pedantic class like this or a regular dictionary like this. Either one works. That's why I want to put both here. And yeah, so you do one or the other. And then we need this library because in Python, async await or asynchronous functions are not built in. I think it's only been around since Python 3.4 or something. So it's not like JavaScript where it was made with asynchronous programming in mind. So Python was started with synchronous programming. So if you want to do anything async, you need to import, I don't know how to call this, but async CO or something. Yeah. So that's how you do this. And then this is just async CO syntax. So you have to do you can't just be run the function. You have to be async co.run. And then this is the actual function that is, actually doing the thing. And we can go up here and we have this function takes into account one URL, which is a string. And then this, I don't know, I call this kworks, but this is another Python syntax where it's you can pass an undefined amount of parameters into a Python function. And if you want to do so, you can just call it this, and Python will automatically understand that that's just a bunch of parameters that might or might not go in there. Other than this, absolutely necessary parameter called URL. So first we take the HTML content, and then in order to do so, we go into this function here. This is called ascrape playwright. So let's unpack here. The reason why it's called ascrape instead of scrape is because it's asynchronous. I found out that this is a Python thing. So I came from a more JavaScript and stuff. And it turns out that in Python, you can just name thing A this and A that, and that just designates, well, not designates, but it kind of signal to other developers that this is asynchronous. And what this thing does is it basically uses this library called playwright, which is a Python library, and actually launch a Chromium browser behind the scenes, and then open a new page in that browser, go to the URL that we pass in from here. And in our example, that URL was AppSumo, which is the e-commerce website, or the Wall Street Journal, which is the news website. So that will go here. And then what we'll get here is just a bunch of HTML. And before we actually use that raw HTML source, I actually wrote a bunch of kind of utility functions to, first of all, remove unnecessary lines, because once you get back HTML raw format, it's very messy and it's a lot of things that you don't need. And part of the reason why we need to kind of clean this up is because large language models have limited context windows. So we want to maximize our usage of that as much as possible. And I'm going to go into like a little bit of details of like how I kind of like manage that to a certain extent. So we remove unnecessary lines. In this case, there's just like /ns, right? It's like new lines. We extract a bunch of tags. So the tags that we want here are just usually when you scrape websites for a while, you'll know that your content usually fall into these categories. So you got the p tags, your l tags, p for paragraph, l for line item or bullet points, divs for making sure that you go into the divs and then you find the p's and the li's, and then a tags for links. And then you kind of remove every other tags. And then after that scraping is done, actually let me go back here real quick. I have two scraping functions in here. So I've tried the first one, which is just I don't know what to call this, but it's like you use this library called Beautiful Soup, and use it by itself instead of using it in combination with Playwright. And I think it doesn't do a good job because a lot of websites don't like when you scrape them in a robotic way, like in a programmatic way. So the reason why I had to go with Playwright was because it actually opened up a Chromium browser and then kind of simulates going to a website. That's why a lot of websites didn't know that I was actually scraping them. But when I was using this, scraping directly with Beautiful Soup, a lot of websites didn't allow me to do that. And, that's legal. They're allowed to prevent you from scraping. You should know that. And so if you go to this website, this file, you'll have access to all these utility functions that I just mentioned. So that's the scraping part. That's the traditional part. And then let me just talk a little bit about this. So going back to here, when you go down to this, so this just means if this file is or the script file main.py is run by itself, then it'll treat this as a library or a module called main. It's just like a Python thing. And the token limit is for GPT 3.5 Turbo is 4,000 or roughly 4,000. There's a 16,000 token version, but I wanted to choose 4,000 just because I'm cheap, even though this is really cheap. And I just declare a couple of example URLs here that you can play around with. You can always change them to whatever you want. And yeah, so we got the so we go down back to like the main function here. So we got the HTML content from Playwright, and we just say, extracting content with LLM, because that's when the next part starts to happen. Our large language model has a context limit of roughly 4,000 tokens. So here is just me limiting the amount of content that I'm sending to OpenAI by just getting the first 4,000 tokens, the 4,000 characters from the source HTML. And then I'm going to pass that into this other function to extract information out of it. So let's go to this function real quick. It's just called extract. And this function is in this file called aiextractor.py, just for, organizing reasons. So in here, you'll see a couple of things. So first of all, I'm going to load the .env information, which is where I keep my OpenAI API key. And you only need to run this and assign the environment variable to this variable here, because this variable is actually a global variable from LangChain. I forgot if it was LangChain or OpenAI, but as long as you assign this value, your key value to this variable, then you're good. And then I'm gonna try to create a chat OpenAI object, which is a LangChain object that kind of encapsulates some of the OpenAI chat model processes. And I'm going to give it a temperature of 0, which means that every time I send a query to this model, I should get roughly the same answer, because temperature is a number that kind of dictates how random every answer that you get would be. So for example, if I send a query of like, give me all the articles from Wall Street Journal that starts with that are under the topic of politics, for example, I should expect to get the same answer every time. So reducing this number, unless you have some sort of creative task, down to 0 is a good idea if you expect it to not go ham on being creative, or aka hallucination. And here I'm just going to declare this my model code name. The reason why I didn't use just GPT 3.5 and I actually use GPT 3.5 Turbo 0613 is because this is the model snapshot, which is kind of like a version of a model that's like frozen in time and they're not actively working on it anymore. This is the version that came out with OpenAI Functions. And OpenAI Functions is a great way to ask a large language model to pick a tool. So for example, you have a toolkit of like 10 different tools. You can check the weather, you can check the stock price, you can call an Uber, and then you ask an LLM like, oh, I need to go to Cupertino in like 10 minutes. Which tool would the LLM choose? Of course, it's going to choose Uber. So that is why OpenAI Functions is a great thing, because it's kind of like a fine-tuned model that's separate from GPT 3.5 if you call GPT 3.5 API. And it decides which function or which tool to use for you for every query that you have. And that comes in very handy because we want to use this to basically extract information out of our user's query. So let me try to remember. Okay, so the query is actually I can show you that. So here's the extract function. This is a custom function. The content here is usually the HTML that was scraped from our website, and then these are just the keywords are just the other parameters. In this case, it's going to be the schema of like what kind of information I want specifically, and then I just have two kind of scenarios here. You can go with one or the other. You can declare a schema in Pydantic, which is a Pydantic class, which is kind of like TypeScript if you're coming from that world, or you can just declare a dictionary and then just declare which keys or which information you want to extract information. So the concept behind this idea, the concept behind this is I think it's called NER, which is like a NLP, natural language processing concept, where you're extracting entities out of text. based on a list of interests that you have of which entity you want to extract. Right. So the reason why we're using OpenAI functions is because they're actually really great at extracting inputs from a user's query and then put that into a different function. Okay, so now we're in LangChain's create extraction chain. So LangChain is kind of like a wrapper library around a lot of the large language model application patterns, because we keep seeing the same kind of patterns happening over and over. So we got like extraction, we got agents, we got chaining prompts together, all that kind of stuff. So this library just makes it a lot easier to do all those things. So we use this create extraction chain function, and inside of this, it creates a LangChain chain, first of all, and this will allow us to interact with the large language model. And then what it's gonna do is it's gonna pass in a extraction template. So this is kind of like when you go on ChatGPT and you tell it to, like, maybe you paste in like a JSON text, and then you at the end you say, from this JSON text, just get me XYZ. So that's what we call prompt engineering, and this is what they have behind the scenes. So they have this default prompt template here. So this is what OpenAI GPT would see. So extract and save the relevant entities mentioned in the following passage together with their properties. Only extract the properties mentioned in information extraction. Blah, 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 blah. So the passage here, because this is a LangChain prompt template, the our scraped HTML content will go in here, and then it will try to look at our schema. I think up here, so it will like kind of extract the schema out, and then trying to like send a request to OpenAI functions, and then all that stuff. So that's how the extract function works. Here, there's just a couple of lines of code to kind of clean up the information displayed by, because there's a difference between when you're displaying, a Pydantic class object versus like a dictionary. Like a dictionary looks a little bit nicer, so I just kind of like convert the Pydantic objects into dictionary, and then display them that way in my terminal. So the way you can improve on this code base is that you can maybe chunk this. So send chunks of your HTML content to your large language model provider like OpenAI, instead of just using the first chunk, 4,000 tokens. And you can even build a fast API server on top of this, so that it can serve you content from any website that you can then use in your front end on your client. So that's pretty much it. With great power comes great responsibility. So only scrape websites that allow you to scrape, and don't do anything illegal. If you like this content, hit the like button, subscribe. We're going to be coming out with a new course on AI agents soon, and I'll leave the link to the sign up form down below. But stay tuned for more content like this. Man, I sound like a real YouTuber now. And that's it, folks.